preaching biblical Christianity to third world nations.
God spoke to the void, and the universe showed up. Our universe contains about 100 billion galaxies, each with 100 billion stars. There are over 100 parameters that had to be precisely, exactly so, for life to exist on our planet. But of course, life does exist, created and sustained by God. Today, there are almost 6.5 billion people in our world. Our cultures vary, yet we share the same miracle, life. The human body is the pinnacle of God's creative genius. Today, science strives to learn more about our past in order to create a better future. Yet as scientists discover what God already knows, the details of a grand design begin to emerge. We should not fear science. God invented science. A clear understanding of what He has done only enhances our view of Him. God's power is undeniable. His precision is impressive. His sovereignty is on display. How can such power fail to dominate our every thought and action, to rescue us from our everyday insecurities? It is not that God has failed to demonstrate His nature. It is just that we are slow to understand. What we need is a new vision of God, the real God. More Than Meets the Eye is a 4-part video series demonstrating a God who is brilliant and wise, powerful and precise, intimate and personal. The more we understand about God's power, the less we worry about our weakness. Richard Swenson, MD, is a physician, futurist, best-selling author, and award-winning educator. He has researched the material you are about to see, and his insight has become his passion. In 2003, the Christian Medical and Dental Associations honored Dr. Swenson with the Educator of the Year award. Dr. Swenson has traveled to over 50 countries for purposes of speaking, practice, or study. He has presented to a wide variety of career, professional, educational, medical, governmental, and management groups, including the Mayo Clinic, the Pentagon, members of the United Nations, and members of Congress. Dr. Swenson is author of 6 books, including More Than Meets the Eye.
Over the first 2 sessions together, we've been examining how science reveals the power, the precision, the sovereignty of God. God's power is undeniable. His precision is staggering. His sovereignty is on display. Let the record show God is impressive. But then why do we live in such a metaphysical stupor? How can this kind of power fail to dominate our every thought and action? Why do we remain so insecure about, for example, the economy, or so anxious about the world? The worst kind of trouble comes when we forget who God is and fail to trust both His power and His sovereignty. You see, it's not that God has failed to demonstrate His nature. It's not that He has failed to instruct us. It's just that we're slow to understand. Perhaps the world is too much with us. Our eyesight is dim, and there is a dimness in our soul. The hymn says, I ask no dream, no prophet ecstasies, no sudden rending of the veil of clay, no angel visitant, no opening skies, but take the dimness of my soul away. We do see through a glass darkly, don't we? Thomas Merton, however, wrote, we are living in a world that is absolutely transparent, and God is shining through it all the time. This is not just a fable or a nice story, it is true. If we abandon ourselves to God and forget ourselves, we see it sometimes, and we see it maybe frequently. God shows Himself everywhere and everything, in people, in things, in nature, in events. It becomes very obvious that God is everywhere, and in everything we cannot be without Him. It's impossible. The only thing is that we don't see it. Let's turn again to science and the scriptures to see what God has for us today. Let's begin by peering into a telescope and observing the story of the stars. In Psalm 19, David wrote, "The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they display knowledge. There is no language where their voice is not heard. Their voice goes out into all the earth, their words to the ends of the world." As we look up, the first thing we encounter is, of course, the universe itself. The scripture teaches us that God spoke to the void and the universe showed up. He created ex nihilo, which means that out of nothing he made something. Out of nothing he made something. Now the mass of the universe is 10 to the 50th tons. I've mentioned that in previous sessions. 1 with 50 zeros after it, tons. That's the mass of the universe. And as we saw in the last session, if we wish to convert this mass to energy, to pure energy, we would multiply it by the speed of light squared. So you have 10 to the 50th tons times the speed of light, which is a very big number, times the speed of light again, which is a very big number, and the end result is a very, very, very large number. Impressive, to say the least. Now let me ask you an additional question here. How much mass and energy have humans made? In all of our years, how much mass and energy have we created? The answer is surprisingly simple. None. Zero. Absolutely none. All the scientists, all the engineers, all the technology, all the R&D budgets have not made so much as a gram or an ounce of mass or a joule of energy. It is precluded by the laws of physics. The first law of thermodynamics states that energy cannot be created or destroyed, and Einstein taught that mass and energy are the same thing, just different forms. So energy and mass cannot be created and they cannot be destroyed. We can change them around, but we can't create them and we can't destroy them. So when we look around us and we look above us and we encounter the universe, we should understand that it speaks of God. It speaks of his power. It hardly needs pointing out that there is an asymmetry here between God and us. We know that this huge universe contains 10 to the 79th elementary particles, one with 79 zeros after it. Elementary particles are like protons, neutrons, electrons, or you could count the quarks which underlie the proton, neutrons, electrons. Now let me ask you a question. Does God know where each one of these elementary particles is all the time? You see, they're always moving around. Does God know where they are all the time? Yes. He knows how many air molecules, for example, you have in your right front tire right now. He knows the precise location of every carbon atom you once used, but is now being used by somebody else. Throughout the entire cosmos, God knows the exact position of every elementary particle every nanosecond. You see, he can't help himself. You say, well, why does he have to bother with that? He can't help himself. This is what omniscient means. You either must believe he is omniscient or he isn't omniscient. And if he is, then we must be prepared to accept the consequences. The level of precision in the created order, as measured by a British mathematician, is 10 to the 10th to the 127th. I'm sorry, but I can't even begin to describe that number to you. I personally don't have a clue. How about the galaxies? Our universe is populated by galaxies. One estimate is there's maybe 100 billion galaxies out there, and each galaxy has on average about 100 billion stars. Most galaxies are either elliptical, in other words, they're shaped like a racetrack, or else they're irregular with no distinct shape. Our Milky Way galaxy, though, is different. It's an example of a spiral galaxy. About 5% of galaxies are spiral galaxy. It's really pretty interesting and quite beautiful, I think. It's flat and round like a pancake, and it spins rapidly around the center. At the center is a black hole, and the galaxy spins like a pinwheel in a hurricane. Our Earth is located out on a distant arm of the spiral, and it spins rotationally around this black hole center at about 500,000 miles an hour. So you thought you were sitting still, but 500,000 miles an hour. One astrophysicist said galaxies are like people. When you get to know them, they're never normal. They found a galaxy last year where a black hole was singing. Maybe that's the wrong word, but at any rate, it was singing B flat, 57 octaves below middle C. And then just recently they found another black hole, maybe in a similar galaxy, that was singing, only this was about an octave higher. Stars seem to be the centerpiece of the heavens. It's so much fun on a summer evening to lay down and just look at the sky, isn't it? With 100 billion galaxies, each with about 100 billion stars, there's somewhere between 10 to the 20th and 10 to the 24th stars out there in the universe. All the stars we see at night, though, come from our own Milky Way galaxy. You can't see the stars from the other galaxies, it's too far away. A star marked the place where Jesus was born. Isaiah 40, verse 26 says, "Lift your eyes and look to the heavens. Who created all these? He who brings out the starry host one by one and calls them each by name. Because of his great power and mighty strength, not one of them is missing." Did you know that a spoonful of a neutron star are small stars, but very, very dense, very compact. A spoonful of a neutron star would weigh 100 million tons. Pulsars are neutron stars that spin rapidly, and as they're spinning, they're emitting these short pulses of radio waves, and some pulsars can rotate as much as 100 times a second. Gamma ray bursts, well, they don't really belong in the stars, but we might as well put them here as anywhere else. Gamma ray bursts were first seen about 40 years ago by some spy satellites that the Air Force had, and astronomers says, what in the world is that? Gamma rays are the most energetic form of electromagnetic radiation, and at times these gamma ray bursts are as bright as the rest of the universe combined. There's a noted astronomer, his name is Alan Sandage. He began his scientific journey years ago as an atheist, but he was overwhelmed by the data to accept the existence of God. He said, quote, "It was my science that drove me to the conclusion that the world is much more complicated than can be explained by science. We can't understand the universe in any clear way without the supernatural." Our own star, the sun, is a miracle. All stars are non-stop thermonuclear bombs, in other words, gigantic perpetual hydrogen bombs. And they generate both light and heat. And of course, that's why we're alive. Helium is the second most common element in the universe, and hydrogen is the first most common element in the universe. And the sun and all stars, all thermonuclear bombs, use hydrogen, two hydrogen coming together to form a helium atom, and in that process a little bit of mass of the two hydrogens is lost, converted into energy, then made into photons. Every second about 4 million tons of the mass of the surface of the sun are converted to energy. That, in the form of photons, screams out across the solar system, and we get 1/billionth of it. One physicist pointed out that the core temperature of the sun is so hot that a pinhead heated to the temperature of the center of the sun would emit enough heat to kill anyone who ventured within 1,000 miles of it. So if I took a pin to the sun and heated it to the temperature of the core of the sun and brought it back here in the Midwest, it would kill everybody within 1,000 miles of it. The sun recently shot loose a solar flare, and it was a gigantic magnetic cloud that came streaming out of the sun toward the earth. This gigantic magnetic cloud measured 30 million miles in diameter and was moving 1 million miles an hour. I read about that and I thought, God is bigger than that. As long as we're in the neighborhood, let's take a look at a couple of our planets. You know the book, Men Are From Mars and Women Are From Venus? Well, Mars seems innocent enough to me. It's kind of like a four-wheel drive theme park. I could live there for a while. How about Venus? Venus is about the size of the Earth, but it takes almost 8 months to rotate once, making for some pretty long days. And the rotation of Venus is retrograde. It goes in the opposite direction. It's the only planet to do this. Its atmospheric pressure is 90 times that of the Earth. Its upper clouds drip sulfuric acid. Its surface temperature is nearly 1,000 degrees Fahrenheit, and there's hurricane winds that whip continuously around the planet, accompanied by repeated lightning strikes and deafening thunder. So ladies, don't blame me. I didn't title the book. Jupiter is by far the largest of the planets. It could hold over 1,000 Earths. It has an extraordinary speed of rotation for being this big. One day on Jupiter is only 10 hours, and because it's rotating so fast, the surface winds on Jupiter are 1,000 miles an hour. But listen to this. Jupiter offers us a wonderful protection. If Jupiter were not positioned precisely where it is, comets would strike our planet 1,000 times more frequently than they do. Saturn wins the beauty contest, hands down. Its rings are not only glorious, but they're gigantic. Saturn is second only in size to Jupiter, and it's about 750 times the volume of Earth. 2 of its moons do a very strange dance. About once every 4 years, their orbits intersect each other, but just before collision, the 2 moons actually switch orbits. Sir Isaac Newton wrote in Principia. He wrote the book in 1687, and Stephen Hawking called it the most influential physics book ever written. And remember, Newton is the one who characterized the universal law of gravity that keeps all of the planets and all of the solar system and all of the universe, indeed, where it is. He wrote in Principia, "Thus God arranged the planets at distances from the sun." Our Earth is a lovely place. We're so fortunate. We are so fortunate. Do you think God's favorite color is green or blue? There are over 100 parameters that had to be precisely, exactly, mathematically so for life to exist on our planet. Our planet's requirements for sustainable life were narrowly and almost impossibly defined right from the very beginning. Not too much mass, not too little mass, not too far from the sun, not too close to the sun, not too far from Jupiter, not too close to Jupiter. The gravitational force had to be precise. The number of stars in the universe had to be precise. The moon had to be just where it is and just the size that it is. Still, many scientists have trouble giving God credit. In the book Rare Earth, written by geologist Peter Ward and astronomer Donald Brownless, they write, "It appears that we have been quite lucky." And then they go on to explain how the development of life on Earth requires a fortuitous assemblage of the correct elements and an intricate set of nearly irreproducible circumstances. They summarize by saying, if some godlike being could be given the opportunity to plan a sequence of events with the express goal of duplicating our Garden of Eden, that power would face a formidable task. With the best intentions, but limited by natural laws and materials, it is unlikely that Earth could ever be truly replicated. Too many processes in its formation involved sheer luck. Their conclusion: it appears that Earth got it just right. Somehow that level of reasoning reminds me of a Calvin and Hobbes cartoon. I think it was a Calvin and Hobbes cartoon I saw years ago. It said, "The surest sign that intelligent life exists elsewhere in the universe is that it has never attempted to contact us." Let's take, for example, the miraculous story of the carbon atom. We've been talking about the existence of life and how difficult it was for the solar system to be as it is, or for life to exist, and particularly complex, sophisticated life as we see in the human body. One Christian chemist called the carbon atom God's autograph. Carbon is the 4th most common element in the universe, and all life that we have ever discovered, or that we think we ever would discover, is carbon-based. The only trouble is that carbon shouldn't exist. It shouldn't really exist at all. Carbon is spectacular in so many ways. It's the only element that has the properties that are needed for supporting the richness of life. No other element can even begin to form the kind of variety of chemical bonds that are found in carbon. Using hydrogen and oxygen and nitrogen and other elements, Carbon can form an almost infinite number of compounds. We have measured over 1 million existing carbon compounds, and many thousands of these are vital to life processes. This property of carbon is unique among all of the elements. Let me tell you a little bit about the story of the creation of the carbon atom. First, 2 hydrogen come together and form a helium, and then 2 helium come together and form a beryllium. The trouble is this beryllium is very, very, very unstable. It only lasts for 10 to the minus 17 seconds. That's like a billionth of a second. So the 2 helium come together, form the beryllium, and it only lasts 10 to the minus 17th of a second. Now, in that amount of time, in order for carbon to form, 1 more helium needs to attach itself to that unstable beryllium in 10 to the minus 17th of a second. Now, in order for this to happen, the nuclear energy levels, or the resonance of the helium, the beryllium, and the carbon must be precisely matched. Precisely matched. An astrophysicist from Great Britain, his name is Fred Hoyle, who died a few years ago. He predicted this resonance number. And then he talked to people at Caltech. He says, could you measure this? They thought he was crazy, but they decided to humor him and go ahead and measure it. And after a week of doing the calculations, it turned out to be exactly, that resonance number turned out to be exactly what Fred Hoyle had predicted. And Fred Hoyle, who was an atheist to his death, said it shook his atheism to the core. Quote, a common sense interpretation of the facts suggests that a super intellect has monkeyed with the physics as well as the chemistry and the biology, end of quote. You see, this number did not have to be that, but it turned out to be precisely that. There's no cosmic universal rule that suggests that number had to be that value, but that's what it was. Can you see the evidence of the genius of God? Well, we started out this session by looking through the telescope into the cosmos and finding God's fingerprints all over it. But as long as we now find ourselves deep into the atomic structures, let's stay here for a while and see if we can't learn more about this precise, majestic God who designed us so perfectly. The last session we examined some of the implications of Einstein's relativity, the world of the very large and very fast. Relativity is bizarre. In the opposite direction is quantum mechanics, the world of atoms and subatomic particles. Quantum mechanics is even more bizarre than relativity. Reality as we know it loses any meaning and it must be redefined. Quantum mechanics is an entirely new way of looking at the subatomic world. It was devised between 1900 and 1930 primarily by 6 scientists, Einstein being one of them, but Einstein hated it. He hated it in a way that I think is really quite charming, as a matter of fact. The quantum world is ruled by such concepts as unpredictability, indeterminism, chance, randomness, and uncertainty. It is important to understand just how much these words and these concepts represented heresy to classical physics. The problem is, rarely can we say anything useful about the future behavior of any single quantum event. Atoms and subatomic particles do not behave themselves. And this is in essence the problem. They are unpredictable. They will not stay put. If you come back tomorrow, you have no way of knowing where you're going to find them. If you tried to sit on them, you'd discover that you're sitting really not on a chair, but on a cloud of probabilities. If you tried to measure them, you would encounter uncertainty. Classical physics preferred precision over probabilities. Actually, classical physics insisted on precision. But it turns out the universe wasn't listening, for the universe proved to be indeterministic at its most basic level. Newton's dream, therefore, of a universal clockwork machine turned out instead to be something like a cosmic game of dice. And Einstein was appalled. He hit the roof. This led to his well-known clip that God does not play dice with the universe. He said that to his Danish physicist friend Niels Bohr, and Bohr wrote back to him and said, Einstein, stop telling God what to do. Einstein wrote in disgust that he would rather be a cobbler or even an employee in a gambling house than a physicist if he had to accept quantum uncertainty. 15 years later, he finally did. But I think if Prozac existed back then, Einstein would have been on it. Physicist Richard Feynman, who died a few years back also, he said, "I think I can safely say that nobody understands quantum mechanics. Do not keep saying to yourself if you could possibly avoid it, but how can it be like that? Because you'll go down the drain into a blind alley from which nobody has yet escaped. Nobody knows how it can be like that." An atom in the subatomic space is almost scary. We think of the atom something like a tiny marble, but an atom is no more like a marble than cotton candy is like a bowling ball. When we put cotton candy in our mouth, it disappears. The same thing happens to the atom when we put it under scrutiny. There's an astrophysicist named Arthur Eddington, and he says, "The physicist draws up an elaborate plan of the atom and then proceeds critically to erase each detail in turn. What is left is the atom of modern physics." An atom is a tiny puff of smoke that stays put. It's weaselly, it's ghostly, it's otherworldly. Physicist Paul Davies said, "Atoms and subatomic particles inhabit a shadowy world of half-existence." Part of the problem is that dimensions at the atomic level are almost all occupied by seemingly empty space. First, the distance between atoms is 1,000 times greater than the size of the atom itself. And second, even the atom itself is almost all empty space. Almost all of the mass of the atom, 99.9% of the mass of the atom, is located in its tiny nucleus. Yet the nucleus of the atom only occupies 100,000 billionth of the volume of the atom. It's tempting to believe that as we extend our thinking down to the quantum world of subatomic size, we'll find everything similar to our visible world, only smaller. In other words, the only difference is one of dimension, but that is not the case. Instead, we find a completely different reality. The dimensions are different to be sure, but so is the very essence of particle behavior. Scientist David Chalmers says, "It is clear by now that all interpretations of quantum mechanics are to some extent crazy. It often seems that no solution to the problem of quantum mechanics can be satisfactory." There's two Oxford scientists that write, "Every quantum bit has the potentiality to be here and there, now and then, a multiple capacity to act on the world." In the quantum world, matter always possesses a certain degree of fuzziness, and it may be doing several different things at the same time. In the 1920s and 30s, spiritually minded people found these postulates of quantum mechanics theologically threatening. They were really afraid of this. Today, however, almost all observers view these findings as instead theologically interesting. I find them hilarious and very, very interesting and humorous at the same time. Quantum mechanics occupies the interface where physics and metaphysics meet. I'm glad God doesn't reveal all his secrets to us. Max Planck, one of the original theorists behind quantum theory, remember I said there were 6 scientists who primarily came up with this, and Max Planck being probably the first in 1902. He was not spiritually shaken by its implications. Instead, he maintained that both science and religion wage a, quote, tireless battle against skepticism and dogmatism, against unbelief and superstition, with the goal toward God. Nobel laureate physicist Charles Townes says, "As a religious person, I strongly sense the presence and actions of a creative being far beyond myself, and yet always personal and close by." Townes believes that scientific discoveries reveal a universe that fits religious views, specifically that somehow intelligence must have been involved in the laws of the universe. If we look into the distant cosmos, we find the amazing hand of God. If we look into the microscopic atom, we find the same amazing hand of God. Partly the hand of God is seen through beauty. Aesthetic sensitivity and harmony were not necessarily a given. God decided on beauty. Sunsets and stars, northern lights and meteor showers, blue oceans and green forests. We should rightfully be grateful that God ordained such elegance. Partly the hand of God is seen through power, whether the extensive power of gravity that holds it all together or the concentrated power of nuclear fusion that fuels the stars and gives us life, or the awesome power of supernovas and quasars and gamma ray bursts. Jeremiah said, "Sovereign Lord, you have made the heavens and the earth by your great power. Nothing is too hard for you." And partly the hand of God is seen through precision. There can be little doubt that to any objective observer that the universe was finely tuned by a genius beyond comprehension. If he has displayed such lavish beauty, power, and precision, why do we have such difficulty resting in his sovereignty? The abundant witness of a created universe leaves no rational excuse for our existential insecurity. If we have a problem with spiritual confidence, it is not from God's lack of revelation. The challenge for us is to understand what the new physics and astronomy and relativity and quantum mechanics teach us about God. For one thing, science confirms that he is brilliant, a super intellect. Additionally, quantum mechanics and uncertainty show us that he can never be pinned down. If we try to put him in a box, he will vigorously refuse the experience. He's mysterious. As soon as we think we understand reality, he redefines it. Even as light is a central defining entity of the life of the universe, he is light. He inhabits more dimensions than our imaginations can deliver. He manipulates time as it suits him. He is unfathomable, just as he said. He is beautiful, powerful, and precise. Let the record show God is impressive. But does he love us? Does he care? Calvary is the measure of the love of God, says J.I. Packer. Lay it to heart.